There are animals that came from different universes. These are the untouchables. NASA, known for its essential revelations, has affirmed that this new planet isn't simply captivating because of its size and location, but also because it shows lights that give off an impression of being artificial. Are we uncovering hidden insights that could change how we understand the universe? Could this discovery point to life on other planets? Join us as we explore NASA's intriguing findings and uncover the truth behind these puzzling lights. In 2007, NASA launched the Dawn spacecraft with a mission to study the most intriguing objects in our solar system. Dawn was equipped with 3 ion engines, allowing it to embark on a remarkable journey. The spacecraft's mission began with a 14-month investigation of Vesta, the second-largest asteroid in the belt. During this time, Dawn sent back detailed images and data revealing Vesta's complex surface and diverse geological features. After completing its first objective, Vesta, Dawn set its sights on the dwarf planet Ceres. Thanks to its ion engines, Dawn could leave Vesta's orbit and travel to Ceres, an undertaking that traditional chemical propulsion would have struggled with. The ion engines provided a gentle, continuous push, allowing Dawn to traverse vast distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of around 950 kilometers, Ceres is not only the largest body in the asteroid belt but also one of the most fascinating due to its unique features. As Dawn approached Ceres, scientists eagerly anticipated the first clear images of this peculiar world. They saw bright spots scattered across its surface, particularly in a large crater, sparking excitement and speculation among researchers. Before Dawn's mission, the best image we had of Ceres was a blurry, low-resolution photograph taken by the Hubble Space Telescope. Scientists knew little about this dwarf planet, and the opportunity to examine it closely was thrilling. What secrets would Ceres reveal? What new discoveries awaited? Dawn was expected to provide valuable insights into the evolution of our solar system and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be composed of highly reflective materials, possibly salts left behind by evaporated water. This raised the possibility of cryovolcanism on Ceres, a process where volcanoes emit water or salty liquids instead of molten rock. But what exactly are these mysterious lights, and what do they tell us about Ceres? Could they be signs of ongoing geological activity, or something even more extraordinary? Ceres stands out from other bodies in the asteroid belt due to its size, mass, composition, and potential for water and ice. Unlike most rocky asteroids, Ceres is more like a comet, suggesting it holds more clues about the early solar system than previously imagined. Following 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This was a significant milestone, as Dawn sent back humanity's first close-up images of the massive object in the asteroid belt. As Dawn drew nearer, the photos of Ceres became clearer, offering us our first detailed look at a previously enigmatic world. The initial images showed a surface dotted with craters, indicating a long history of impacts. But it wasn't the craters that drew attention. Among these features were unusual bright spots, contrasting with the darker, rough terrain. As the photos improved in resolution, scientists speculated about the nature of these spots. Were they patches of ice reflecting sunlight, or could they be something even more intriguing? Some suggested they might be mineral deposits or signs of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single feature, but possibly a combination of several distinct regions. This discovery deepened the mystery. These spots might be salt deposits left behind by evaporated water, supporting the idea that Ceres once had, or still has, some kind of geological activity that moves water or briny liquids to the surface, where they quickly evaporate, leaving reflective deposits. The presence of such features hinted at the possibility of subsurface water or salty pockets, which could have significant implications for the potential for life in our solar system. What makes Ceres so significant compared to other planets? Ceres is often described as a cold planet with an extreme yet delicate surface. Unlike most asteroids in the belt, which are mainly composed of rock and metal, Ceres stands out due to its unique composition. Its surface is a mix of water, ice, and hydrated minerals like clays and carbonates, making it less dense than its neighbors. This suggests that Ceres contains a significant amount of water. Its surface is rough yet porous, with ice and other substances trapped within. This icy nature is more like that of a comet than a typical asteroid, hinting at a past that may have involved both rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more fascinating aspects of its structure. The dwarf planet is thought to have a layered interior with a slushy mantle and a core. The mantle is believed to be rich in water ice, making up about half of Ceres' total volume. This icy layer, possibly mixed with rock and salty water, surrounds a denser core, likely composed of silicates. The large amount of water ice suggests that Ceres may have once had liquid water, especially if its core was heated by radioactive decay in its early history. This structure sets Ceres apart from other asteroids and raises intriguing questions about its potential for geological activity and the role of water in its development. Furthermore, the discovery of ammonia clays on Ceres suggests that it might have formed in a colder, more distant part of the solar system before moving inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface salty water. These findings not only enhance our understanding of Ceres, but also offer key insights into the formation and evolution of icy bodies in the solar system. Cryovolcanism is a fascinating geological process vastly different from the volcanoes we see on Earth. While regular volcanoes erupt molten rock, cryovolcanoes, also called ice volcanoes, emit substances like water, ammonia, or methane in liquid or gas form. These materials can exist in cold environments like Ceres. Cryovolcanoes work by allowing water mixed with salts to rise to the surface. When this salty water meets the vacuum of space, it quickly evaporates, leaving behind bright reflective salt deposits. These deposits form the bright spots on Ceres' surface. The most famous of these spots is located in a crater known as a crater, specifically in a region called Spot 5. This area has drawn a lot of attention due to its high reflectivity and mysterious hazes observed by the Dawn spacecraft. Among the surface features, scientists discovered ridges, flows, and deposits that hint at geological processes beneath the surface. The combination of bright spots, surface features, and composition tells a story of a world that has experienced both external impacts and internal activity over billions of years. One of the most striking features on Ceres is Ahana Mons, a massive cryovolcano that rises approximately 4 kilometers above the surface. Unlike traditional volcanoes on Earth, Ahana Mons appears to be composed of icy material with a relatively smooth and young surface. This suggests that it was formed by cryovolcanic activity in the recent geological past, possibly as recently as a few 100 million years ago. The existence of Ahana Mons reinforces the idea that Ceres is not a static world but one that has experienced, and may still experience, changes. The cryovolcanic processes that formed this icy mountain are thought to have been driven by subsurface briny liquids, which could periodically rise to the surface through fractures or pressure-driven mechanisms. Another intriguing aspect of Ceres is the presence of organics, carbon-based molecules that are fundamental building blocks of life. In 2017, NASA announced the discovery of organic compounds on Ceres' surface, particularly in an area near the Ernetet crater. These organics are believed to be native to Ceres rather than delivered by impacts, suggesting that the dwarf planet has its own chemical processes capable of producing such molecules. The combination of water, salts, and organics on Ceres raises the possibility that the dwarf planet could have once harbored conditions suitable for microbial life or might even still possess subsurface environments where life could exist today. Although no direct evidence of life has been found, Ceres remains a prime candidate for future exploration to answer these profound questions. The Dawn mission provided humanity with an unprecedented view of Ceres, shedding light on a world that was once shrouded in mystery. The spacecraft operated around Ceres until 2018, when it finally ran out of fuel and ceased communication. However, the wealth of data it collected continues to be analyzed by scientists, uncovering new insights about this fascinating dwarf planet. Ceres, with its bright spots, icy surface, and potential subsurface ocean, challenges our understanding of the solar system. It shows that even small bodies can be geologically active and complex, with the potential to reveal secrets about the origins of water, organics, and possibly even life in our cosmic neighborhood.